here's one question that can be a little bit fiddly, and I'm going to approach this from two different directions. So the question is, you're dealt 5 cards from a deck of 52, okay, and we're asking what's the probability that you have exactly 2 aces, okay. I'm going to approach this again using our kind of counting rule. So the probability of 2 aces, and when I say 2 aces I mean exactly 2 aces, not 3, not 4, but exactly 2. Okay, so we're going to approach this by saying this is the number of ways you can get 2 aces divided by the number of ways of dealing 5 cards from a deck of 52. Alright, now I'm going to approach this from 2 different directions, one in terms of permutations and then one in terms of combinations, okay? And then maybe if time I'll discuss it from one further way which we'll cover in more detail a bit later, but it doesn't hurt to show now, okay? Alright, so first let's do it with permutations. We'll also need a little bit of combinations as well. So if we're thinking about permutations, we've got our 1 to 52 cards here, okay, and we're imagining on the table there are slots where we're going to put card 1, we're going to a position where we'll put card 2, card 3, card 4 and card 5. Okay, and we're imagining we're dealing them out and we care exactly about the order. Okay, so here, remember there's 52 cards that can go here, and then 51 cards that can go here once we've placed one here, then 50, 49 and then 48. Okay, and this is the total number of ways I can lay down 5 cards in order. Okay, so that's 52 5, 52 5 permutation. Okay, right, so that gives me the total number of ways. Okay, and I'll add a little bracket, so this is when the order matters. So effectively what we're doing here is we're writing down a list of cards that have been dealt, and then we'll have, like, this is ace of diamonds, then next we might have the jack of spades. I'm very bad at drawing a spade. You know, 2 of hearts, 3 of clubs, you know, and then maybe another ace. Okay, the ace of spades, for example. Okay, all right, so we're actually writing down a list where the order matters in that list. Okay, and we're counting the number of ways that can occur. Okay, so now let's have a think about we need to count the number of ways of getting 2 aces out of this. Okay, so let's have a think about the number of ways of getting 2 aces. So one easy way to think about it is to first think about the number of ways that the first 2 cards that you're going to get out are aces. Okay, so we want card 1 and card 2 to be aces, and card 3, card 4 and card 5, okay, to be non-aces. Okay, so in that case there are 4 things that can go in here as an ace. Okay, so we want this to be an ace and this to be ace and these to be non-aces. Okay, ace, ace, not ace, not ace, not ace. So there's 4 things that can go here. Okay, and then once we've specified 1 ace to be here, there's 3 aces remaining that we can choose here. Right, and then with the remainder here, well, we've got 48 cards which are not aces. Okay, so 48 things that can go here, right, and then 47 things that can go here, and then 46 cards which are not aces that can go here. Alright. So in other words, we could think of it like this, that notice this is equal to, the total number of ways of doing this is 4, 2 times the permutation of 48 and 3. So why is that? Well, effectively what we're doing is we've got ace 1, ace 2, ace 3, ace 4, okay? And then we've got a separate deck of cards, we could imagine, that are cards 1, 2, numbered up to 48, so all the cards which are not aces. And we're saying we're going to deal here for the first 2 cards from this deck, and then we're going to deal for the following 3 cards C5 for the following 3 cards from this deck. So this is the number of ways of dealing 2 cards where the order matters from this deck, and this is the number of ways of dealing 3 cards from a deck of 48 cards. Okay? Alright, now, so that gives us the number of ways where the first 2 cards are an ace, okay? Where we care about the order which the cards arrive. Alright, then notice that within this there are alternative ways. It could be that we consider the first card to be an ace and the last card to be an ace and the 3 cards in between to be not aces. Or we could consider the number of ways at which the first 3 cards are not aces and the last 2 cards are not aces. Okay? And notice for each of those, the number of ways that that can occur is the same. Right? So we're essentially asking what's the number of ways I can have an ace, ace, and 3 non-aces out of these 5 cards. Right? So we're saying I've got sort of card 1, card 2, card 3, card 4, and card 5, and I'm asking now what are the number of ways I can label on top of here ace, ace, not ace, not ace, not ace. Right? So in other words, what we're really doing is we're thinking of how to put these 5 cards into 2 bins where there's a set for the aces and for the not aces. So how many ways can I combine 2 aces amongst these 5 cards? Which we know already is the number of ways of combining 2 cards out of 5. 5, choose 2. Okay. So for each ace, ace, and then following not aces, there's 5 to choose 2 ways of combining that with this. Okay. So what we're going to end up with is that the number of ways of 2 aces is equal to, well, firstly, the number of ways where it's just ace, ace, non-ace, 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 and then all the ways that we can have ace, ace somewhere in this deck, okay, which is 5, choose 2. Alright, so then we arrive at an answer that the probability of 2 aces exactly, okay, is equal to 4 permutation 2, 48 permutation 3 times 5 choose 2 divided by, as we saw at the top, 52 permutation 5. Okay, so here. Alright, so we can calculate the answer for that. So I'll just use my little kind of script here. So we've got 4 permutation 2 times 48 permutation 3 times 5 combination 2 divided by permutation of 52 and 5. Okay, and that gives me an answer of about 4%. Okay. Okay, so that's one way of doing it. It's quite an explicit way of writing it out. We actually individually list each card. Okay, so we're looking at card 1, card 2, card 3, card 4, card 5. Okay, another way to approach it would be via combinations. Okay, here we're looking at the hand that we get and the numbers of different hands that can occur. All right, so let's have a look at this slightly different approach, which uses combinations more and permutations a little bit less. Okay. Okay, so now we've got our $52 cards, and now we're asking how many ways can I split this up so that I get 5 cards. 1, 2, 3, 4, 5 cards here, and the remaining 47 cards are left in the deck. Okay, so then, well, the number of ways of splitting up 52 cards into sets of size 5 and 47 is given by 52 choose 5. Okay, so this is the total number of hands that we're going to get. So, just to compare with the approach we were taking previously, before we were counting the number of ways at which we could get, for example, in that order, the number of ways we could say get ace of diamonds, jack of spades, 2 of hearts, 3 of clubs, and ace of spades. Okay, now, so there's, and if we swapped any of the elements, that would be a different order or a different set of cards. Now we're looking at the same thing, but we don't care about the order anymore. So we're looking at the set here, where we get ace of diamonds, jack of spades, 2 of hearts, 3 of clubs, and ace of spades. Okay, notice here the order didn't matter. It didn't matter that the ace of spades was the last card. It could have been the first card. It doesn't matter the order which it was dealt. Right. So now we need to enumerate the number of sets that we can get out of our deck where there are exactly 2 aces. Right. So now we need to count the number of hands or sets where there are exactly 2 aces. Okay. So, well, let's think of it like this. We need to count up the number of ways we can get an ace, and then a non-ace, a non-ace, and a non-ace. Okay, we could take an approach a bit similar to before. We could think of it having 2 decks of cards. Okay, we've got a deck that has just the aces in it. Okay, a smaller deck, and a larger deck which has the cards up to 48. Okay, how many ways can I choose the 2 aces out of here and put them in this bin? Well, there are 4 choose 2 ways. I can choose 2 cards and put them in here. And here there are 48 choose 3 ways. I can take 3 cards out of here and put them in here. Right? So the total number of distinct ways I can make sets, which consists of 2 aces and 3 non-aces, is this. 4 choose 2 times 48 choose 3. Okay? So then, from that, I get that the probability of 2 aces is equal to 4 choose 2 divided by 48 choose 3 divided by 52 choose 5. Okay, so let's just double check that it's going to give me the right answer. So I've got 4 choose 2 times 48 choose 3 divided by 52 choose 5. And I get exactly the same answer again. Okay? Answering this question where we have 5 cards dealt at random from a deck of 52, and we ask what's the probability that you get exactly 2 aces. Okay, we haven't quite covered all the material for approaching the question this way, but I find it a fairly intuitive approach nonetheless, and we'll explain a little bit why we can do things in later parts of the course. Okay, so let's imagine we've got our deck of 1 to 52 cards. We're going to deal out the cards. Card 1, card 2, then card 3, card 4, and card 5. Okay, and we're going to ask what's the probability of getting an ace, then something that isn't an ace, not an ace, something that's not an ace, and something that's not an ace. Okay, so when the first card is dealt, there are 4 aces in the pack and 52 cards. So the chance of an ace is 4 in 52. Okay. Next, now, after that first ace has been dealt, there's 51 cards in the deck, and 3 of which are aces. So there's a 3 in 51 chance that the next card is an ace. Next, there are now 50 cards in the deck, of which 48 are not aces. Okay, so there's a 48 in 50 chance that the third card is not an ace, given that the first 2 cards are aces. Okay, now, next, there's 47 non-aces in the deck since we've dealt one of the non-aces, and there are now 49 cards. Okay, then finally, okay, for the last one, there are 46 non-aces in the deck out of 48 cards. Okay? Now, what we can do is we can multiply together these probabilities, okay, to get the chance that we get ace, ace, no ace, no ace, no ace. Okay? I'll explain a little bit later why that's the case, but it's something to do with the fact, say, that given this has happened, we now know we can now calculate the probability of this event occurring. Okay, so given this, we multiply by the probability of this. Okay, I'll explain that in a little bit more detail in a later video. Okay, so we can calculate this together, and notice this is for the combination where the first 2 cards are an ace and the next 3 cards are not an ace. All right, but that doesn't account for all the ways we can get 2 aces out of this. This is where the first 2 are an ace and the rest are not, but there's 5 choose 2 different combinations where we could say have the ace, ace, and then non-aces for the first 3 cards, or maybe the 2 middle cards here are aces and the other cards are non-aces. Okay, so the total number of ways of combining those 2 aces out of those 5 is 5 choose 2. So I have to multiply this by this total number of ways of combining. Okay, and we can check that this indeed gives us the same answer as well. All right, so if we go here, okay, so we're looking at 4 over 52 times 3 over 51 times 48 over 50 times 47 over 49 times 46 over 48 times 5 choose 2. So we can see we get exactly the same answer again. Okay, so there's 3 different approaches to going about doing this calculation, right?